Have you ever stopped to ask why light moves at the speed it does? Not why it's fast, but why the universe seems to have chosen that exact number. Most people think the speed of light is just a property of light. It isn't. It's woven into the very fabric of space and time itself. Stay with me, because once you see why light has this speed, you'll never look at reality the same way again. Have you ever noticed that when people talk about light, they usually talk about how fast it is? They say it travels at nearly 300,000 kilometers every second. They say nothing can go faster. And because we've heard these facts so many times, we tend to stop being surprised by them. But I think we're surprised by the wrong thing. The real mystery is not that light is fast. The real mystery is why there is such a thing as a maximum speed at all. Think about it. If you throw a ball harder, it goes faster. If you build a more powerful car, it goes faster. If you design a better airplane, it goes faster. In ordinary life, speed seems to be something you can always increase if you have enough ingenuity and enough energy. So why does nature suddenly draw a line and say, no farther than this? That is the question. Now, many people imagine that light is special because it somehow decided to move very quickly. They picture light as some champion racer of the universe, winning every contest and leaving everything else behind. But that picture turns out to be completely backward. Light is not setting the speed limit. The speed limit is setting light. That sounds strange at first, but let's see where it leads. Imagine you are standing on a perfectly straight road that stretches forever. A car passes you at 50 kilometers per hour. Another passes at 100. Another at 200. Nothing seems unusual. Every new car simply moves faster than the last. Now imagine asking a simple question. What is the fastest speed that information can travel? Not cars, not rockets, not bullets. Information, suppose something happens on one side of the universe. How quickly can the news reach the other side? This question turns out to be much deeper than it appears. Nature could have been built in many different ways. Information might have traveled infinitely fast. Cause and effect could have spread instantly everywhere. The universe might have had no speed limit at all. That is not the universe we live in. Instead, there is a specific speed built into the fabric of reality itself. A speed that acts like a universal conversion factor between space and time. And light just happens to travel at that speed. The more physicists studied electricity and magnetism, the stranger things became. They discovered that electric fields and magnetic fields are not really separate things. They are intertwined aspects of a deeper structure. When the equations describing these fields were solved, an astonishing number appeared. A speed. Not an arbitrary speed. A very specific one. And when scientists calculated it, they found it matched the measured speed of light. At first, this seemed like a curious coincidence. Then they realized it wasn't a coincidence at all. Light is an electromagnetic wave. The equations were not accidentally predicting some random number. They were revealing a fundamental property of nature. But that still leaves us with the biggest question. Why that speed? Why not twice as fast? Why not 1,000,000 times faster? Why not instantaneous? To answer that, we need to stop thinking about light and start thinking about space and time. Most people imagine space as a giant empty stage where events occur. Time is imagined as a separate clock ticking away in the background. It feels obvious. Space is space. Time is time. Completely different things. But nature doesn't agree. The deeper we look, the more space and time seem woven together into a single fabric. And once you realize that, something remarkable happens. The speed of light stops looking like a property of light. Instead, it starts looking like a property of reality itself. Imagine drawing a map. Normally, a map has horizontal and vertical distances. You can move north, south, east, or west. Now imagine a map where one direction represents space and another represents time. Suddenly, motion becomes a path through this combined landscape. Every object traces out a route through space-time. You are doing it right now. Even sitting perfectly still, you are moving through time. Every second of your life is another step along your path. Now, here's the fascinating part. There is a certain relationship between space and time built into the geometry of this space-time. And that relationship contains a special number. The number we call the speed of light. In other words, the speed of light emerges from the structure of reality the same way the properties of circles emerge from geometry. A circle doesn't choose to have a particular ratio between circumference and diameter. That ratio simply follows from the nature of geometry. Likewise, light doesn't choose its speed. Its speed follows from the geometry of space-time itself. This changes everything. Because now we understand why every observer measures the same speed for light. Suppose you are moving in one direction while someone else is moving in another. Common sense says you should measure different speeds. After all, that's what happens with cars and airplanes. Yet light refuses to cooperate. No matter how you move, no matter how fast you chase it, the measured speed remains the same. This sounds impossible until you realize that space and time themselves adjust to make it true. Distances change. Time intervals change. Not because nature is trying to trick us, but because space-time has a geometry unlike anything we encounter in daily life. The universe protects this fundamental speed the way ordinary geometry protects the properties of a triangle. It isn't a rule imposed from outside. It is a consequence of the structure itself. And suddenly a profound idea emerges. The speed of light is not merely telling us something about light. It is telling us something about the architecture of existence. Every star that shines, every atom that vibrates, every signal crossing space, every event that has ever happened, all of them are operating within this framework. The speed limit is woven into the universe at the deepest level. And once you see that, another mystery appears. The universe could have been different. The fundamental constants of nature could have taken other values. The laws themselves might have had another form. Yet somehow our reality possesses exactly this structure, exactly this geometry, exactly this maximum speed. And from that single fact flow some of the strangest consequences ever discovered. Time slows for moving clocks. Lengths contract. Mass and energy become interchangeable. Entire technologies, from particle accelerators to GPS satellites, depend on these effects being real. What began as a question about light ends up transforming our understanding of space, time, matter, and reality itself. That is why the speed of light remains one of the most important clues nature has ever given us. It looks like a simple number in a textbook. But hidden inside that number is a message. A message telling us that the universe is far stranger, far more elegant, and far more interconnected than our everyday intuition ever suspects. And perhaps the most beautiful part is this. The deeper we investigate the speed of light, the less it becomes a story about light, and the more it becomes a story about the hidden design of reality itself. Now let's push the idea even further. Suppose you had a spaceship unlike anything ever built. Imagine engines so powerful that every second they pour unimaginable amounts of energy into the ship. Day after day, the engines fire. week after week, year after year. Common sense says the ship should eventually exceed any speed you choose. After all, if more energy means more speed, then enough energy should mean unlimited speed. That seems perfectly reasonable. But nature has a surprise waiting. The ship gets faster and faster, yet the closer it approaches the cosmic speed limit, the harder every additional increase becomes. It is almost as if reality begins to resist. The energy does not stop entering the ship. The engines are still working. Nothing is broken. Yet less and less of that energy appears as additional speed. The universe is not saying you are not allowed. The universe is saying something much stranger. It is saying that your idea of speed, energy, space, and time must all be reconsidered together. This is one of the most beautiful moments in physics. Instead of patching the old picture with extra rules, nature forces us to abandon the old picture entirely. The mistake was never in the mathematics. The mistake was in our intuition. For thousands of years, human beings evolved at speeds that are tiny compared with the speed of light. We throw stones, ride horses, drive cars, and launch airplanes. In all these situations, the speed of light is so enormous that its effects remain hidden. It is like living your entire life on a perfectly calm ocean and concluding that waves do not exist. The waves were always there. You simply never experienced conditions where they mattered. The same thing happens with relativity. At ordinary speeds, space and time behave in ways that seem simple and independent. Only when motion becomes extreme do we begin to notice their deeper connection. Consider a thought experiment. Imagine a spacecraft drifting through empty space. Inside is a traveler carrying a flashlight. Every second, the flashlight emits a pulse of light that bounces between two mirrors. Up, down, up, down. The traveler uses these bounces as a clock. Each round trip marks the passage of time. From the traveler's point of view, the light moves straight up and straight down. Simple enough. But now imagine observing the spacecraft from far away as it moves across space. For you, the light does not travel straight up and down. The mirrors are moving sideways while the light travels. The light follows a zigzag path. And here is the remarkable part. The zigzag path is longer than the straight path. The light must travel a greater distance. Yet the speed of light remains the same. So if the distance is greater and the speed is unchanged, something else must change. Time itself. The moving clock ticks more slowly, not because it is defective, not because some mechanical part is malfunctioning. The slowing is built into reality. A clock made from light slows, a clock made from gears slows, a clock made from atoms slows. Every physical process slows. The universe treats them all equally because time itself is behaving differently. This idea sounds impossible when first encountered, yet countless experiments have confirmed it. Particles created high in Earth's atmosphere survive longer when moving rapidly. Atomic clocks flown on aircraft return with measurable differences. Satellites orbiting our planet must account for relativistic effects every day. Nature repeatedly tells us the same story. Time is not absolute. And once that realization takes hold, the speed of light begins to appear in a new role. It is no longer merely a speed. It becomes a bridge connecting space and time. Imagine trying to compare kilometers with seconds. At first, they seem completely unrelated. One measures distance, the other measures duration. How could they possibly be linked? Yet the speed of light connects them directly. It acts almost like an exchange rate between space and time. A certain amount of space corresponds to a certain amount of time through this universal constant. Without that connection, space-time as we know it would not exist. Now another question naturally arises. Why does light itself move at this special speed? Why doesn't an electromagnetic wave travel more slowly? To see the answer, think about what a light wave actually is. Many people picture light as some mysterious substance racing through emptiness. But a light wave is really a self-sustaining dance between electric and magnetic fields. A changing electric field creates a magnetic field. A changing magnetic field creates an electric field. Each one continuously regenerates the other. The wave carries itself forward through space, like an endless chain of cause and effect. What determines how quickly this dance unfolds? The answer lies in the properties of empty space itself. That may sound strange, because we usually think of empty space as nothing. But empty space is not nothing. It possesses measurable characteristics. It responds to electric fields. It responds to magnetic fields. The strengths of those responses determine how rapidly electromagnetic disturbances can propagate. When physicists inserted those properties into the equations, out emerged the famous speed, not because anyone put it there by hand, not because anyone decided it should be that value. The number emerged naturally from the structure of reality. This is one of the reasons science is so satisfying. The deepest truths often arrive unexpectedly. You begin by studying electricity, then magnetism, then waves. Then suddenly a fundamental speed appears, a speed that turns out to govern the entire universe. A clue hidden inside equations long before anyone fully understood its significance. And the more closely we examine this speed, the more peculiar it becomes. Imagine for a moment that light traveled infinitely fast. The instant a star exploded on the far side of the galaxy, we would know immediately. Cause and effect could spread without delay. The entire universe would share a single universal now. That sounds simple. But simplicity can be deceptive. Without a finite speed limit, the structure of space-time would be profoundly different. The distinction between past, present, and future would change. The relationships between events would change. Much of modern physics would collapse into an entirely different framework. The finite speed of light is not an inconvenience added to nature. It is one of the ingredients from which nature is built. Think of a game of chess. The rules may seem restrictive. Why can a bishop move only diagonally? Why can a knight move in an L shape? Yet those limitations create the richness of the game. Change the rules, and you create a different game entirely. Likewise, the speed limit of the universe is one of the rules that shape everything we observe. Stars form within it. Galaxies evolve within it. Atoms obey it. Radiation obeys it. Even information itself obeys it. This raises an even deeper possibility. Perhaps the speed of light feels extraordinary only because we are asking the wrong question. Perhaps we should not ask why light is so fast. Perhaps we should ask why human experience is so slow. Compared with the scale of everyday life, light seems impossibly rapid. A beam can circle Earth many times in a single second. It can travel from the moon to Earth in little more than a second. It can cross vast planetary distances while we barely finish a sentence. But from the perspective of the universe, perhaps this speed is simply fundamental. Not especially fast, not especially slow, just woven into the structure of space-time the way angles are woven into geometry. The universe is not trying to achieve that speed. The universe is built around it. And once that thought enters your mind, many familiar ideas begin to look different. Motion looks different. Distance looks different. Time looks different. Even the concept of here and there begins to change. Because every location in the cosmos is connected through the same underlying framework, governed by the same fundamental relationship between space and time, a relationship that quietly reveals itself whenever light moves through the vast darkness between stars. And so after all of this, we arrive at a surprising realization. The greatest mystery was never why light is so fast. The greatest mystery is that the universe possesses a speed woven so deeply into its structure that space, time, matter, energy, and information must all obey it. What began as a simple question about a beam of light has led us to something far more profound. We discovered that light is not the ruler of the universe, it is the messenger revealing the rules. Every flash from a distant star, every signal crossing space, every moment of cause and effect is quietly reminding us that reality is built according to principles far deeper than our everyday intuition. Perhaps the most humbling lesson is this: the universe is under no obligation to make sense to common sense. The world we experience each day is only a tiny glimpse of a much larger reality. A reality where time can stretch, distances can shrink, and the very fabric of existence is stitched together in ways that seem impossible until nature shows us otherwise. And that is why curiosity matters. Because every time we dare to ask a simple question, why is light so fast? Why does nature work this way? Why does the universe have these rules? We pull back another corner of the curtain and discover that reality is more elegant, more mysterious, and more beautiful than we imagined. The speed of light is not just a number. It is a clue that the universe is not random chaos, but a deeply connected structure waiting to be understood. And perhaps the most extraordinary thing of all is that a collection of atoms on a small planet orbiting an ordinary star can look into the cosmos